about conic sections. You're going to learn about what happens in the many ways that we can slice a cone. We can slice a cone perpendicular to the tip, and then we get, or the vertex, and then we get a circle. We can skew that slightly, and that turns into an ellipse. We can slice it perpendicular to the axes, and we get a hyperbola. And if we slice it diagonal, we get a parabola. So today we're looking at parabolas, but the conic sections are all of those different kinds of shapes we get when we slice cones. This is going to be a new way of thinking about parabolas, circles, and hyperbolas. So the new definition of parabola is it's the set of all points that are the same distance between a line and a point. The line is called the directrix, and the point is called the focus. There are no points, those are not on the parabola, but if I pick a point that's on the parabola, like A here, it's going to be the same distance from the focus as it is straight down to the directrix. And that's true for every single point on the parabola. If I pick a point on the parabola, it's going to be the same distance from that point to the focus as it is from that point straight down to the directrix. What we're going to be interested in today is the vertex of the parabola, the focus of the parabola, and the equation for the directrix. With this new definition of parabola, we can also have sideways parabolas. So for the first time, we're going to have parabolas that face the other way. So the right side up parabolas that we're used to are going to have a squared on the x term. And the sideways parabolas are going to have a squared on the y term. When we're finding the focus and the directrix, if the parabola is facing the normal direction, then the directrix will be a y equals equation because it will be a horizontal line. And we will also change the y coordinate of the vertex in order to get the focus, but the x coordinate will stay the same. If we're on a sideways parabola, the equation for the directrix will be a vertical line, so it will be an x equals equation. And the x coordinate of the vertex will change, but the y coordinate will stay the same as we're finding the focus. The directrix, the focus, and the vertex are all going to line up. They're all going to be the same distance apart. So our first example is this is already in the kind of the standard form. So this is the standard, not the standard form of a parabola, but the standard conic form of a parabola. If we want to find the vertex, that's going to be h comma k. So the vertex is going to be, for this parabola, it's going to be +5, -2, because we're going to change both of those signs because our equation has a subtraction in both places. So this is going to be 5, -2 for the vertex. The next thing we're going to do is we're going to figure out what P is. Since 4P is the number in front of the parentheses here, we're going to do a little tiny bit of algebra and say 4P is equal to 20. We'll divide both sides by 4, and so for us, P is equal to 5. Okay. When we're finding the focus of the parabola, because it is a vertical standard orientation parabola, we're not going to change the x coordinate. So the x coordinate is going to stay a 5. But for the y coordinate, we're going to take our old y coordinate and we're going to add p to that. P is positive, so we're adding a positive number. That's going to give us a point that is 5 units higher than the vertex. So this point is going to be 5, 3. That's my focus. And then the last thing we're going to do is we're going to find the directrix. The directrix is going to be an equation, the equation for a horizontal line. So it's going to be y equals. And to get the directrix, we're going to take our y coordinate of the vertex, which is -2, and we're going to subtract p. Since p is positive, subtracting p is going to move our directrix 5 units down. So that is our equation for the directrix. If I'm going to draw this parabola, if I'm going to graph it, the parts that you have to do correctly, that I have to be able to see that you can do, is I have to be able to see that you can graph 5, -2, and that you know that that's the vertex, and that you can graph the directrix, which is y equals -7, 3, 4, 5, 6, 7. So there's the directrix. And then you can graph the focus, which will be 5, 3. So this is the focus, this is the vertex, and this is the directrix. And then you're going to graph a parabola, and we're not going to be picky about points today. We're just going to graph a parabola that opens in the correct direction. This parabola opens up because it's always, the focus is always going to be inside of the parabola, but also because the p-value is a positive value. This distance is 5. This distance is 5 because that is our p for this parabola. Okay. In this example, our parabola has a squared on the y term. So that means that this parabola is going to be a sideways parabola. And before we can do anything, we need to make it look like this form of the equation. So we have to do completing the square to make that happen. What we're going to do first is we're going to move all of the terms except for the y terms to the other side of the equal sign. So I'm going to add 4x and I'm going to add 35 to both sides of my equation so that this thing only has y's on one side, and that's it. So 4x plus 35. And now just a refresher on completing the square, we're completing the square on this y side. We're saying if I have a perfect square and I did the area model, I would have a y squared right here. And if it's a perfect square, these two diagonals are going to add up to -2y, and they're going to be the same size. So in order to add up to -2y, each of these diagonals is going to be -1y. Now I'm going to move to the outside of the box, and I'm going to figure that the dimension here is going to be y, and the dimension here would be -1, -1, and then the missing piece, the part that I'm completing when I complete the square, is that there's a missing 1 in this corner because -1 times -1 would be 1. So in order to fill in that missing 1, I have to add 1 to both sides of my equation. I'm completing the square by adding 1 to both sides of this equation, and it's this 1 that I'm adding. Now I'm going to rewrite my equation. This expression is the area of this box. The dimensions of this box, the length times width, would be y minus 1 times y minus 1, which is y minus 1 squared. I got that from the dimensions of the box. These we know multiply to make that area, so that side of the equation is done. And then on the other side, I have 4x plus 36. Well, I can factor a 4 out of both of these two terms, so I have 4x plus 9. And so this is now in the standard conic section form for a parabola. It is a sideways facing parabola. It is opening to the right because p is positive. So if I find my three things, my vertex is going to be 1, -9, because I need to change the sign on both my x and my y coordinate. Oh, I did it backwards. My vertex is not 1, -9. My vertex is -9, 1, because the x-coordinate is on the other side of the equation. My p-value, I'm going to solve for p. So p would be, well, 4p is 4. So when I divide both sides by 4, I get that p is 1. So for this parabola, the p-value is 1. That means the focus, the directrix, and the vertex are going to be 1 apart from each other. The focus of the parabola is going to be, we're going to change the x-coordinate this time. So we're going to take -9 plus 1, comma 1. So our focus is going to be -8, comma 1. And then for the directrix, we're going to write a vertical line equation. So our vertical line is going to be x equals -9 minus 1. So that means that our directrix is going to be at x equals -10. If I graph this parabola, I'm going to have a directrix at -10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is going to be my directrix. It's a vertical line. Oops, that's a +10. I'm going to go this way. My directrix is going to be a vertical line. I'm going to have my vertex at -9, 1. So this is my vertex. And then I'm going to have my focus at -9, 1. Sorry, my vertex is up here. And my focus is going to be at the same y-coordinate, but it's going to be 1 to the right of that. And so my parabola is going to be sideways facing. It's going to open this way. All I'm looking for in your graphs is that your vertex, your focus, and your directrix are in the correct location, and that your graph opens in the correct direction. Your parabola kind of hugs its focus, so that should help you find the direction. The direction is also based on the p-value. If the p-value is positive, then your parabola is going to open in the positive direction. On the x-axis, the positive direction is to the right. On the y-axis, the positive direction is up. All right. Here's a quick summary of my sources for this work. I got some equations and a GIF, and I used a template for this note. Thank you so much. Bye.